Hey, thanks for watching this session. My name is Jan-Klaas Kestelot, and I'll be talking to you about Data API and scripted connectors. Data API and scripted connectors is something relatively new in DataMiner, and this session will teach you all about that and tell you the ins and the outs of that new capability of DataMiner. What we're going to see in this session, we'll start with an introduction first. And then we're going to focus on Data API and on scripted connectors. So actually, this functionality comes twofold. There are two angles to it, and we'll handle both. We'll then do a hands-on session. You can do an exercise, and I'll guide you through the exercise. And we'll finish off with an overview of the limitations of what we currently have. So let's get started. At the end of the session, what you will be able to do, what we will accomplish is, first of all, the idea is that you understand the concept of Data API. Secondly, you will recognize and know the advantages of using Data API and when not to use Data API, because it's not always the best solution for the problem you're trying to solve. We have to be honest with that. And then finally, you will also create a scripted connector to leverage Data API. But let's start with the beginning. Let me start with the introduction. What is Data API and scripted connectors all about? Yeah, of course, we need to start somewhere. Before we begin, Data API and scripted connectors is still in preview. You can enable that with the Data API soft launch option. If you spin up a DataMiner in the cloud, if you spin up a DaaS system, Data API is enabled by default, so you don't have to worry about that there. If you want to do that on an on-prem system, you will need to look in the help on how to activate the soft launch. Good. What is Data API and scripted connectors? What is this all about? Well, you can summarize it very easily. It is actually an easy way to start integrating devices, products into DataMiner without needing to develop a full-blown DataMiner connector. DataMiner connectors today are, in fact, XML coded. There is a lot of features and there's a lot of functionality with XML connectors today. Full-blown stack. We have been doing this for over 20 years. Lots of capabilities. With Data API and scripted connectors, we are offering a alternative to bring data into DataMiner in a more easy and a more convenient way. It's more easier to get started and get your data in DataMiner. It's a twofold approach, or I'm going to split it up into, on the one hand, we have a Data API, which is a HTTP API that receives HTTP requests. So that's going to get the data into DataMiner. That data will then be automatically put into elements, and you will see them showing up in DataMiner itself. And on the other hand, you also have the HTTP clients, you might say, that send the data to Data API. And we call those scripted connectors. Today, these scripted connectors run on the DataMiner system itself. And we support Python and PowerShell scripts. And these will scrape or get the data from the devices and transmit those into JSON, or with using a JSON format, sorry, and send them to Data API. Let's have a visual representation of this. So we have on the left-hand side our equipment, our data sources, our products that we want to get data from. And on DataMiner, we create scripted connectors. Today, as I said, we support PowerShell and Python script. By default, these run every minute. This is fixed at the moment. That's a limitation that's going to show up at the end of the presentation. These scripted connectors fetch the info from the devices and then send it as JSON to Data API. And Data API will then put that data into elements, and they will pop up there. In the backend, or internally, DataMiner will create connectors on the fly, auto-generated connectors, because of course elements are created with connectors. Yeah, we all know that. But instead of you creating the connector XML following a specific schema and so on, these connectors are automatically generated, making it very convenient for you to get your data directly into DataMiner. Okay, I think that's what I needed to say about that figure. Very specifically, let's have a very specific example, very small example. I have a JSON file or the JSON example on the slide. If you would send to Data API a JSON with this key value pair, so we have a server name and the value is web server, we have a CPU utilization, and here we have a number 78.5. We just take that JSON, we send it to Data API. What will happen is you will see an element popping up, in a matter of speaking, into DataMiner, and that element is going to have exactly those parameters. I'll have a CPU utilization with the value, and I'll have a parameter server name with the value web server 001, what I actually, of course, send to Data API. If I would send another request to Data API and the CPU utilization changes, of course, we're going to update that value. As we receive updates, that goes without saying. By default, all the parameters are trended. That makes perfect sense for numbers. We will probably disable automatic trending for strings in one of the upcoming versions of Data API. Nevertheless, you can still always change or tweak the trending template if you want to do that. So even today, although everything is trended by default, feel free to go in, change the trend template, and uncheck the trending for the parameters you don't want to trend. Finally, the JSON example, which is here, is quite straightforward. It's a key value pair. That also, well, I want to say that there is no JSON schema that we enforce. The concept or the idea is really that you get the data from the equipment. A lot of equipment today expose HTTP interfaces which give you JSON back, and that actually with the JSON that you get back from the equipment, you could just leave it untouched and send the same response to Data API, which will then put the data in DataMiner. Good. So, why you should use it? What are the advantages of Data API and scripted connectors? It's very easy to get started. There's no specific scheme or syntax. In its simplest form, you query a product or a service, you get a JSON response back, and that's literally what you send to DataMiner, and you will have the information. It's what you send to Data API can be run in as a Python script. It can be a PowerShell script, but in fact, any language that you want to use to send the HTTP request, is supported. That doesn't really care or Data API doesn't really care about the client code or the scripting language that you use. Whatever suits you the best, whatever works in your scenario. If it can send HTTP, you can get started. So it's very easy to use. So that's the easy part, Data API and scripted connectors. On the other hand, we of course still have our standard connectors. We have a gazillion standard connectors on the catalog. It's a very full-featured syntax, very mature. We have been using this for over 20 years. You can add additional logic with C# if you use quick actions. Standard connectors are also support DCF if you want to expose SRM functions. That's really where you should be looking at standard connectors. And I think that kind of summarizes it. So it's not, and I want to be clear about this, it's not that one is going to replace the other or that one is better than the other. They exist together and they simply have different use cases, let's say. Good. So it all starts with the API, data API that will receive HTTP requests. So let's have a closer look at that API itself. I'm just going to go a bit deeper into that. So the data API exposes an HTTP endpoint on this URL /API/data/parameters. There is no JSON schema. You already know that by now, but you do need to put in some headers in the HTTP request. And there's two headers that you need to put in. On the one hand, there's the identifier. The identifier really identifies the source equipment and has to be unique in the DMS cluster. For example, if you're going to integrate water meters and the water meter has a unique identifier in the network, use that as an identifier to data API. Yeah, we really have to be sure that the identifier also is unique in the cluster. Initially, that identifier will be used as the element name in the cluster. You can still change it later on and rename the element as you would normally do. So even if your identifier is, for example, a MAC address, initially the element will be a MAC address in the cluster. But of course, you can change it. Second header is the type. The type is used to group identifiers together, let's say, to be able to easily manage them later. All my water meters have different identifiers, but they're of the type water meter. Yeah? That makes it easy to manage those elements because in the backend, all these elements will have the same connector, and you will be able to use alarm templates and trend templates and apply them to all these elements with the same type. So this type is used as the name for the auto-generated connector in the backend. From a visual point of view or a graphical representation, I have a couple of services, GitHub and Vimeo, and they expose status information, and they do that with an API that they have in common. So they actually expose the same API to give status information. And that's what we're going to use as well in the example. So the scripted connector will send an API request to GitHub, and it will get back the status of GitHub. In the backend, we will create a automatic or auto-generated connector of that type, and you see that the type is the same. So we have a type status page and another type status page. So they will have the same connector, and then there will be an element called GitHub status, which will reflect the status of GitHub, and there will be an element Vimeo status, which will reflect the status of Vimeo. Let's have a look in real time what that actually means or how it looks like in the DataMiner system. So in the protocols and templates module, if we have that set up, you will see a connector called status page. Note that there is an icon here that indicates that this connector has been automatically generated by Data API, sorry. There is a version, and with that version, you can, of course, assign alarm templates, and there will be a default trend template, which is enabled and activated. And then here you see my different elements of GitHub status. If you would open the protocol, so the auto-generated protocol, if you open that, you can see the contents of that connector. And it will simply have the parameter definitions based on the JSON that was sent. And importantly, this protocol is read-only. Data API generates those. Data API is managing those, so you can't change them yourself. Otherwise, it would conflict with what DataMiner tries to do. Good. So in the example that we started with, there was a very simple example with server name, CPU utilization. Very easy. However, we also support JSON arrays in Data API. If you send us a JSON array, we're going to translate that into a table in the element. We also support nested arrays, and that will be translated or converted into multiple tables with foreign keys. Let's have a look at that. On the right, I have a table or an array, sorry, called people, and that array has a couple of entries, and each entry has an ID, a name, an age, and a height. And we have 3 in total. Yeah. This will be translated in DataMiner in a table. Yeah. We're going to have a table called people. That table is going to have 3 rows with an ID, a name, an age, and a height. Yeah. The ID field that we have in the JSON array, if that's specified, that will be used as the primary key in the row. Yeah, so as you see here, 1, 2, 3. Also note that JSON arrays end up in their dedicated page in the element card. So the people table is put in the people's page. The parameters page, I did not mention that. The parameter page contains the JSON data, which is not in an array. So previously, the server name and the CPU utilization, well, they were actually put in the parameters page. And every single parameter is collected in the parameters page. That was a table. Now you can nest arrays as well. And the example here, we have, let's see if that works. And if you can read that, let's hope so. We have a VLAN table. The VLAN table has the list of VLANs. We have an ID, a type, a description, and then we have a nested array in the VLANs table, a nested array for the connected devices. And that connected devices array again has 2 entries. What does that mean? So what does that mean? It means that in the connector or in the element, you're going to have a connected devices table here with actually all the devices, in this case 4, 2 for VLAN 1001 and 2 for VLAN 1002, but they will be linked with a foreign key to the VLAN. So you have a VLAN foreign key pointing to VLAN 1001, and you see it as well. So this 1001 links to this VLAN 1. Yeah. So nested arrays are translated into tables linked with a foreign key in DataMiner. Okay, now maybe you noticed, maybe you didn't, but if you send information to Data API, we don't have any units by default. In the very beginning, we send a CPU utilization, I think, yeah, you kind of assumed, oh, that's the percentage. Yeah, probably it was, but we're not quite sure. So by default, there are no units. Of course, you need to have units. Yeah, if we talk about bandwidth, yeah, what is it? Kilobits, megabits. We need to make that available, but you can configure that, and that's through the configuration endpoint. So no units by default, but you can configure it. I'll show you how to do that in one of the next slides. Also, when it comes to numbers, the decimal precision that we're going to use by default is decimal precision of the first value that we receive. So the CPU utilization, if we first receive it and initially it had 0.5, so just one decimal, that's what the decimal precision is going to be, even for the next updates. If you want to change that and you want to make it 2 digits for precision, you can also change that with the config endpoint. Yeah, so temperature, you probably want to have degrees there. Memory utilization, I don't know, percentage, number of megabytes used. We'll have to configure that to make that visible. So at the top, we have the default behavior, no units, and the default precision. If to the config endpoint you specify decimals and the units, we'll change that in the element. So to the config endpoint, you do have to send a JSON. That JSON is no longer free form. There is some kind of scheme you have to use there. To configure the decimals, you have to mention decimals, and then you mention the parameter name, and you say, look, I want to have a precision of 2. Temperature, I want to have a precision of 1. So you notice the CPU utilization on top had 0 decimals. Here it has 2. The temperature had 2 initially, and now it just has 1. To configure the units, you use units as a fixed indicator, and then again you specify the parameter names and you specify the units that have to be put on the parameter. So that's Data API. That's the API running on DataMiner. It accepts JSON, single values, arrays, which will be translated into tables. Nested arrays will be translated into tables linked with foreign keys. No units, but you can configure them. A default decimal precision, but you can change that. And the parameters are put in the parameters page all together, and the tables end up in their dedicated page. And of course, we update that on the fly as we get incoming requests. Parameter values are updated, and in the backend, we use auto-generated connectors for that. Now, what will send the data to Data API? Something that sends HTTP. Today, we have scripted connectors. Scripted connectors run today on a DataMiner agent, and you can see them and you can manage them in the data sources module. So in Cube, if you go to the data sources module, of course, you need to have the soft launch enabled first. You will have a user interface that will allow you to create a scripted connector. We actually also use the word data source. So you create a data source, and there you put in your scripted connector. It's gonna run every minute, sorry, and you should see elements popping up. So Python and PowerShell script today. These run on the same agent as the Data API is hosted on, because Data API is only exposed locally today. However, on that server itself, where you have Data API, if you're using another kind of language to call or to do HTTP calls to that local API, that's going to work as well. Yeah, let's be honest about it. And then you are in control of the timings. And you can have other timings if you want to, but you won't see them popping up here in the data sources module. Yeah, that's completely up to you then. Good. Let's have a look and do an exercise. We'll start from an example Python script that we're gonna start with. We'll create a scripted connector of that, and we'll see how the scripted connectors create elements and how we get the data into DataMiner. Good. To do the example or to do the hands-on exercise, you can follow this link. This will take you to a GitHub repository, and the example or the exercise is to change the status page, or to use the status page, sorry. This is a Python script. In this Python script, we will fetch the status information from GitHub. In fact, the example is really written for GitHub, but you could also do it for Dropbox, for Vimeo, and there's probably other services online that use the same API and that you could also use. Good. I'll maybe do the Dropbox example. And for that, I'll change the scripts. So for the exercise, in a bit, you could just copy paste what you have here, or you could go a little bit more advanced and have use one of the alternatives, and that's what I'm gonna do. So I'll go for the Dropbox status. The URL was kindly provided in the comments. Okay. Good. And then the header parameters. Notice, yeah, you need to specify the identifier. You need to specify the type. And then this Python script will get the URL and specifically do this request on status.dropbox.com. And that's exactly, so that response is exactly what we're gonna put or send to Data API. Now, before we do that, let's have a look at how the JSON looks like and see if we can understand and maybe predict how the element is gonna look like in DataMiner. Status. So the URL that I'm gonna fetch with the scripted connector is actually something like this. Voila. It gives me a JSON back. And this JSON has a couple of simple values: ID, name, URL, time zone, updated at. And it also has an array of components, and each component has an ID, a name, a status, and so on. So what I expect to see, if I fetch this or if I get this from Dropbox, is that in DataMiner I'm going to have an element which has a couple of single parameters at the parameters page, and then I'm also going to have a components table on its dedicated components page, and these will be the columns in that table. Let's have a look and let's try to do that. I'm copying, and I just need to connect again to my data sources module. Well, in the presentation, you see that the data sources module is embedded in Cube. Actually, you could also directly access that. If you go to your DAS system or to your host, I made a mistake. Yeah, here we are. So onto my host. Let me already open the monitoring app. And I'll go to data sources. I'll go to data/sources. So you can directly access the user interface as well. Now I'll create a data source. This was for Dropbox. So I'm going to call it Dropbox status, sorry. I'm copy pasting the script that I just changed, yeah, so that contains my changes with the URL changed and the service changed. I'll create the script. It is a Python script. It's not a PowerShell. It is a Python script. Create that. This is my new one. This morning I created those, but this is my new one. It's gonna kick in and it's gonna create the element for me. The ones that I created this morning are here. They are running. You also see that I actually created and assigned an alarm template to those. And that's the reason why I have alarms here, obviously. But let's maybe wait for the Dropbox to pop up. And there it is. So this is my Dropbox page. And what I see is, well, basically what we expected to see. We have some single parameters and we have a components page that contains the components table. Yeah, so these are the components that Dropbox reports about, and this is then the state as well. Let's go back to the presentation. Yeah, so do the steps, you have it in the presentation as well. We changed the service name. We also changed the URL API. We copy pasted that, and then in the data sources module, you go to data sources, you create the data source, you give it a name, you select Python, and you paste your script there. And if you create, then you're going to see that element pop him up, just like we did, or just like I showed you a couple of minutes ago. So what I see is my components page and the components table in there. Good. If you've done that exercise, take a screenshot of the parameters page, upload it on Dojo, and we'll be happy to give you 75 DevOps points for the effort. And of course, it's very nice that you actively work with us on this. Good. Data API, scripted connectors. I think by now you understand what it is not, and I hope you also understand how powerful it is. Today, we do have limitations, and it's only fair that I give you those limitations. With Data API, payloads cannot be bigger than 1 megabyte. Everything else is rejected. There is a rate limit, so you can't send more than 5 requests per second. And Data API also only accepts requests when they're sent from the local host. However, we do have a user-defined API that you could use as a proxy, and then you could send requests from the outside to Data API. You could use that as a proof of concept until we have a proper support for external requests. Good. You also notice that the parameters that are being generated on the element are put on pages. You can't change that. You can't change the layout of your element cards. It is what it is. If you want to make a different visualization, you should really be looking into creating a dashboard, creating a low-code app, or creating a visual overview that goes on top of the element. And then you have free control over the information you want to show and how you show it. Scripted connectors are used today for monitoring. So you pull or you scrape the data from GitHub, for example, and the data that you get back, you put it in DataMiner. We don't have any control mechanism today. Scripted connectors are executed every minute. That is also a fixed frequency. We will look into making that configurable in the future. There is no support for arguments, meaning that, if you do an API call and the API call is the same, but you want to do it for different services, you actually have to have multiple scripted connectors configured and running. The example of GitHub and Vimeo is a good one there because it's actually the same logic, only the endpoint is different. It would be nice if you could just have a single scripted connector that you could say to run for the different endpoints. The scripted connectors are stored locally on the server. They're not synchronized in the cluster neither. Those are also some limitations you have to be aware about. Good. We are almost at the end of the session. I also talked about configuring units and decimal precision. That was not covered in the exercise. However, if you want to have a go, please do. If you want to have a go on the same GitHub repo as we've used before, you'll also find there an advanced exercise where you will be creating a scripted connector, and then also you will be changing units and decimal precision by sending a request to the config endpoint. So feel free to have a look and share the results. Okay, and to wrap up, these are some resources, documentation, how to install it, how to use it. And the data API is also exposed with, or also has a Swagger that comes with it. You can access that if you have an on-prem deployment. You can access that Swagger as well. Well, that's the end of the session. I hope you were able to finish the exercise. I'm looking forward to seeing all the screenshots arriving here in our inboxes. Thank you for watching and hope to see you soon. Bye.